Boom, boom, boom. Hello, everyone. This is Real Talk, Real People. As always, wanted to invite you guys on this cloud architecting journey. It's a good day. Just want to do this quick one, on-premises to cloud migration. Really surface level, really basic, quick one. Hope you guys enjoy it. If you have any questions, please feel free to comment, message. Don't know who that is in the comments, but could be a spam bot. I don't know. But we'll go ahead and get to it. So this will be, again, a very basic on-premises to cloud migration. Don't forget to like, comment, subscribe. And, of course, if you're looking to go ahead and get into cloud computing, maybe get your certifications, just learn the basics, continue to follow the channel. I'll actually, depending on how these videos do, I may create a whole nother channel, Cloudy by Nature, and go ahead and do exclusively cloud content on there. So stand by. If you hear the music in the background, that is Deep House Gentlemen YouTube 24/7 Deep House YouTube music channel. They're in the description. They're actually some of the best music I like to listen to when I'm studying, architecting, or whatever. So check them out. They're great. Also, check out Ja Big. I'll put him in the description as well. He's actually my favorite Deep House DJ out of Montreal, Canada. Great guy, too. He rides across Canada and the United States for charity. Really, really good, solid guy. Soul really comes through his music. So without further ado, let's go ahead and take a look and see what we're going to do here. So we're going to go ahead and create a diagram for a cloud migration strategy. So let's show you what we're looking at in regards to the on-premises layout. So we're going to have the users. Put them here. We're going to have the internet. And let's just say that on this on-premises, they have a collection of web and app servers. Let's just say they have 2 web servers and 3 app servers. So this is actually not going to go directly to an app server. Remember, from the internet, we got to go ahead and push it through a load balancer. So that's just typically what will be on premises. You're going to see that's going to be mirrored in our cloud environment as well. But they have a load balancer that gets them their web servers to the internet. So let's go ahead and put a load balancer. We said 2 web servers. We did say that. Okay. And then we're going to just route that load balancer to the web servers. Duplicate that. I don't want to do that. What do we do? Oh, thank goodness for the undo button. It gets a little tricky navigating the tools a wee bit. Okay. Now, from there, we're going to need another load balancer that's going to connect the app servers because that's what's within the premises. So I'm going to go ahead and put that there. And these lift and shift, you're going to see, for the most part, there's a couple of different migration processors or strategies we're actually using. But this is going to generally look almost like a lift and shift, but there's going to be a bit more to it than that. So let's throw in another load balancer, duplicate that, put that there. Duplicate, undo. That's what happens when you go fast. And you really want to take your time with this. I'm just trying to do it fast enough for the ease of the video. There we go. Well, sorry, we can do it this way. Hope everyone's doing well today. It is Wednesday. Well, depending on where you're at, maybe Thursday. I don't think there's anywhere where it's Tuesday, but it's one of those days. All right, so now we're going to go ahead and create our app servers that are present. And I think I said there was going to be 3 of those. Now, again, this is general. You'll usually know how many, gigabytes these servers are, so on and so forth. More in-depth information about them. But again, this is just to give you a general idea. But generally speaking, you'll want what you have in the on-premises architecture to mirror what you will have in the cloud to make sure everything runs smoothly. Sometimes when people will do migrations at particular data centers, they'll upgrade, but that's called something else actually. Now, the app servers, per the on-premises, they're going to have a database, which is where all that information comes from. And they also have a standby database for this particular traffic, to go ahead and help. So we'll put, for the load, not traffic. Forgive me. You rarely find, not rarely, sometimes you'll find one database, and other times you'll see that they have a database and then a standby database. So on this particular on-premises, it's going to have a standby database as well. So let's duplicate that in case that there's any failure in the database. Redundancy is the key. Put SB for standby.
Gentleman in the mix.
All right, so that's pretty much the bones of the on-premises. So we got to make our cloud architecture look virtually the same, but we're going to increase some availability. We're going to increase the availability, and we're also going to increase the scalability of this by adding a few different things and going from there. And then we're going to make sure that it gets routed correctly through traffic, through to the internet safely through a particular domain name server. So we're going to be adding a domain name server. We're going to be adding an auto scaling group for scalability, domain name server to connect it to the internet. We're going to increase the availability by going ahead and duplicating what we have in the on-premises among two availability zones or two different areas. In case that one area goes down, it can be presented and failed over to a different availability zone. And that's just one way of going ahead and making sure the architecture is safe, it keeps working, and you have minimal downtime. And then we will be done with the basic overview. Now it says AWS Cloud, but it doesn't have to be AWS. I'll show you a neat little trick to take off the AWS. We go down to Style. And then
nothing so safe.
get rid of that, I believe. Perfect. You can just put generally cloud. We're still going to have users, so we can duplicate that. We're still going to have the internet. Yes, we will. We can duplicate that. I said we are going to add a domain name server. So, affectionately known as DNS.
You trusted him and gave him your love. A love he proved.
In AWS, you would call that Route 53. With domain name server, you can buy domains with that as well. Same premise. It's still going to need a load balancer, so we can go ahead and use a load balancer from there. We can duplicate that. But there's going to be a difference here. So you see how we have all of this here? We're going to pretty much duplicate this among two availability zones or two different areas. So we can actually, let's do this. And get rid of that. Replace that for virtual private cloud. We can expand out. And we can make some appropriate changes to tailor this. Let's expand this out. We're going to delete that. Oh, let's go back. We're going to specifically delete. Actually, we can keep that. We're going to delete this here. And we will call this one Availability Zone 1. But really, we're just putting availability zone to just show it's going to be in one area in the cloud, and then we'll put it in another area. So for lack of a better term, we'll just use AWS's terminology, availability zone 1. We could, or let's not do that. Let's just call it, let's say this on-premise cloud wants it hosted in, let's just say, Florida. So let's just say Florida. We'll put North Florida. And then it's going to be hosted in South Florida as well. North Florida. You can actually duplicate that and put this in South Florida. We'll name that South Florida. Just so you guys can know what we're talking about. And like I said, we're duplicating. Now, we're going to make, this is a 3-tier modern architecture, means there's a web service tier, there is a application tier, and there is a database tier. That's what makes a 3-tier web cloud diagram application. We're not going to keep the standby database within the same North Florida cloud because, again, we want to increase the availability and decrease the chance of overall object failure. And the best way to conceptualize a tier, I like to kind of put even more emphasis on these areas, these boxes. So I like to encase each tier to show you, okay, this is a different tier, this is a different tier, this is a different tier. It just helps. Well, maybe that would be easier to just put web. Well, you know it's tier. Maybe I'll write something different. All right, so not to confuse you, I see there's a lot of lines going to a lot of places, so let's get rid of that. Let's get rid of that line. We'll call this the app tier. Tier, whatever helps you better conceptualize it. Database tier. And boom, so there's that. Now we're just missing a few things. So let's get rid of that. Let's expand this. Boom. Now within this, we're going to need a auto scaling group. for these and then remember the load balancer right here, it's still applicable, but we're going to need a load balancer, another one as well. We're going to put that right here. Let's go back. One click will do you.
Gentlemen in the mix.
I'm going to hook that there. And then you know what we're going to do. We're going to duplicate that again. Weird that it's over there. But, yeah. And you see the synergy going right there. Boom. So get rid of that. Okay. So let's look at this in a holistic view. Let's bring it out a little bit. Okay, maybe not. Let's bring it in a little bit. Okay. So what do we have here? What did we do? We went ahead and took the basic on-premises infrastructure that we had, and they said, hey, you know what, we would like to migrate to the cloud. How are we going to do this? Now, what they wanted to see is what their infrastructure would look like if they're asking for higher availability and higher scalability. And how, they wouldn't use those. They may use the term availability and scalability, but how do we secure those? We secure those by taking apart their on-premises infrastructure and putting it in a way that on the cloud that allows for more. Security is another thing, but the ability for it not to go down in the instance of power failure in a particular city or area or something like that. So they had on their on-premises, they had a database and they had a standby database. So what we did there was create a database tier or layer in the cloud where we have the regular database will now be in North Florida in the virtual private cloud. And then we took the standby database, instead of keeping it in North Florida, we put it in South Florida. So let's say there's an issue in North Florida where the power goes out, the hurricane or something like that. Well, in South Florida, it'd still be going, so you'll be able to transfer all of that load onto the standby database where it's constantly syncing. There you'd have read replicas and things like that. That's a whole different story. That's a bit more in depth. Then you have your app servers here. Now, they told us to run their processes on premises, they need at least 3 app servers. So what we did was duplicate that 1-to-1 in 2 separate areas. So we have full redundancy, 100% availability, 100% scalability. Let's say they need more servers than this. Let's say this is an e-commerce website and they're really busy. So they need more servers to take on the load. That's where we get our auto scaling group, which will automatically, at a certain threshold, CPU threshold, storage or usage threshold, it will spin up new web servers to be able to, or application servers to be able to handle the load that's coming from the users and by way of the internet. There we go. Boom. Now, and we have the load balancers to help with that. So we have the auto scaling groups, which will automatically do that. And then the load balancers will spread out the load here to make sure that all of these are working and being utilized to the best degree. The traffic's evenly distributed among all of the servers. And this will keep performance looking very, very good. And these load balancers will have those traffic requests equitably distributed. So load balancers to equitably distribute the traffic and the reading and writing and all of that. And then you have here the load, that's for the load balancers, the auto scaling to increase the ability and the power to add more machines by scaling horizontally, which will allow it to continue to have the same performance even with higher traffic. And then the domain name server, again, that's to go ahead and be our buffer between the internet and our system, our cloud system. So we got a cloud, and within the cloud, we have a virtual private cloud. Now, of course, in any sort of architecture, there's going to be security layer, but for the basics of understanding, just understand these are the meat, these are the bones, the structure of a basic on-premises to cloud migration. There would be a firewall layer to protect, and that can be added as well. But for right now, that's what we have. I hope that was helpful. Let me know. Again, these are just some trial videos to see if you guys have an interest and taste for this. This is worth creating a channel for. If this is worth, giving you guys a dose of technical, actual tutorials on how to diagram, design these cloud infrastructures. So let me know in the comments, comment, subscribe, share, and let me know if there's anything you guys would like to see. Any migrations, lift and shifts, just anything you'd like to see. And we'll see if we can make it happen. As always, have a wonderful and safe rest of the day. And this is Real Talk, Real People. We're out.